Hi everyone, today I'm going to talk about Turbo Autoencoder, which is a channel coding solely via deep learning. First, let's introduce what is channel coding problem. Channel coding is the backbone of modern communication system. It's set as this. You have a binary information at the left side, and then this information is passed through an encoder to add some redundancy to become your code. Your code goes through a channel typically modeled as additive white Gaussian noise channel, and it's corrupted. With the decoder, you can reconstruct your original information. This has been studied extensively for the last 6 decades by Shannon and his followers, and quite a few capacity approaching code have been there in the communication system. For example, RDPC code, turbo code, and Polar code. However, we want to ask is, can we replace the encoder-decoder by neural network to automate the search of the code to see if AI-based code could do something? So if you just directly use a general-purpose neural network, for example, CNN or RNN, the performance won't be very well. That's shown here. On high SNR, there's no coding gain, and also it's very hard to generalize to longer block lengths. In our result, if we use our design, the new structure and new training algorithm, actually you can see the turbo autoencoder shows comparable performance compared to canonical handcrafted code under medium block lengths. And also, turbo autoencoder also have a block length gain, which means as the block lengths become longer and longer, you can get better performance, which is not shown if you just use CNN or RNN as your encoder-decoder. So the major contribution comes from the structural design. This new structure we are introduced here is inspired by turbo code called interleaver. Interleaver means you shuffle your sequence according to a known order, and deinterleaver means you shuffle it back. So with interleaver put on your structure, you actually can allow the encoder to attend very long-term dependency. And on the decoder side, you can use a learnable structure to learn the dependency. And this is actually another version of belief propagation algorithm. And if you have a well-designed training algorithm, you can actually train a very good performance. So in summary, turbo autoencoder shows pretty good reliability compared to modern code, and it also shows very good reliability compared to non-AWGN channels. And the key factor of this good performance is architectural innovation by introducing interleaver and iterative decoding, and also the training terminologies, training algorithms. And that actually shows channel code can be attacked by an alternative approach other than just use purely mathematics. Our code is already public, and we will show our results on Thursday morning.